In current session, we are going to deal with a special case and a simplex method termed multiple optimal solution. So far, we have already dealt with the special case, that is infeasible solution. Today's session will be about multiple optimal solution. So let's get started with the problem. Given a problem, maximize z is equal to 2x1 plus 4x2 subject to three constraints: 2x1 plus x2 less than or equal to 18, 3x1 plus 2x2 greater than or equal to 30, x1 plus 2x2 is equal to 26, and our non-negative restrictions which states that all our decision variables should be greater than or equal to 0. Now the first step under simplex method is to convert inequality into equality, which means that the operators that have been given over here, less than or equal to type, greater than or equal to type, and equal to type, has to be converted into an equality type. So over here, as per the rules that have been already discussed in the class, the first STC, we see that the operator is less than or equal to type. So when we have a less than or equal to type operator, we introduce a slack variable to convert the STC into equality. That is, in this case, we have done 2x1 plus x2 plus the slack variable s1 is equal to 18. The second constraint is greater than or equal to type. Therefore, we subtract the surplus and add an artificial variable. So our second STC becomes 3x1 plus 2x2 minus s2 plus a1 is equal to 30. Coming down to the third constraint, which is already in equality form, but as per the norms of the initial simplex table, we introduce an artificial variable. So therefore it becomes x1 plus 2x2 plus a2 is equal to 26. So we have converted the inequality into equality by adding slack, surplus, and artificial variable. Now once we have introduced these particular variables in the STCs, these variables are supposed to be introduced in the objective function also. Now we see that our objective function is z is equal to 2x1 plus 4x2, which we will try to maximize. So the objective functions has been altered, that is, we have written 2x1 plus 4x2 and made provision for the variables that we have added, that is one slack and one surplus, s1 and s2, with a coefficient 0, which means that slack and surplus variable do not contribute in any way to our profit. So therefore its coefficient is 0. The artificial variable are non-existent variable, and we try to eliminate these particular variables in the due course of solving the problem. So therefore these particular variables have a coefficient in the form of m. In OR terminology, it is some very huge penalty. So if you are solving a maximization problem, the sign for the artificial variable would be minus m. If it was a minimization problem, you would have written as plus ma1 plus ma2, showing that the artificial variable is a penalty in the problem. This being a maximization problem, you are going to introduce it with a negative penalty, that is minus ma1 and minus ma2. Whatever variables you have added in the objective function in STCs has to be reflected in your non-negative restrictions also, which states that all your variables x1, x2, slack and surplus, s1 and s2, artificial variable a1 and a2, all are greater than or equal to 0. Now once this particular step is done, we will move towards making up of our initial simplex table. That is, in this particular case, we are going to transfer this particular data, which we have converted into equality, in the form of a table. That would be a first iteration. Now coming to this particular table, it has a standard heading, that is the first row that you see stands for CJ. CJ stands for coefficient of objective function. The objective function, which was written as 2x1 plus 4x2 0s1 plus 0s2 minus ma1 minus ma2, in our simplex table we will try to split it, that is, we will separate numbers from the variables. Coefficient and variables would be separated. So we write it in this form: 2x1 plus 4x2 plus 0s1 plus 0s2 minus ma1 and minus ma2. Similarly, the number of rows that we will have in a particular simplex table will depend upon the number of constraints we have. In this particular problem, we are having 3 constraints, so therefore we will have 3 rows, one for each constraints. Now coming to the column, the first column stands for CB, which is coefficient of basic variable. The next column is for BV, which stands for basic variable. The third column is for SV, that is solution value. So first let us understand about the basic variable, as we have already dealt in the class. In the basic variable column of the initial simplex table, we will have the last variable of our STC after being converted into equality. So these are our 3 constraints. We have converted them into equality format. This is the left hand side of our constraint. So towards the left hand side, the last variable is S1. So that particular thing would be recorded in the basic variable column S1. In our second STC, the last variable on our left hand side is A1, which will be taken as a second basic variable. And the last variable on the left hand side of our third STC is A2, which will be recorded as a third basic variable. Once this particular column is being filled, we'll get back to the first column, that is coefficient of basic variable. The coefficient of basic variable S1 in the objective function is 0. So we are going to record the same. Similarly, the coefficient of objective function of A1 in the objective function is minus m. Similarly, for A2 also it is minus m. So we record minus m for both A1 and A2 as the coefficient of basic variable. Now coming down to filling up this particular remaining table, under the solution variable column, you will have right hand side of your STCs. That is, when you come to the constraints, the three constraints that you have, on the right hand side you are having 18, 30 and 26. So you will put it up under solution variable column 18, 30 and 26. Now the rest of the table will get its value from the constraint. That is, first row gets its value from the first constraint. So your first constraint reads as 2x1 plus x2 plus s1. So you are going to write down under x1 it is 2x1 plus 1x2 plus 1s1. We do not have s2 in the first STC, so therefore s2 values will be given 0. We don't have artificial variables also in the first constraint, so therefore its value will be written as 0. The second row will get its value from the second constraints. As you see that the second constraint reads as 3x1 plus 2x2 minus s2 plus a1. So therefore we'll post it over here under x1 3x1 plus 2x2. We do not have s1 in the second constraint, therefore it will be written as 0, minus s2, therefore we have recorded as minus 1, plus a1, therefore plus 1, and 0 a2 as we do not have a2 variable in our second STC. Coming down to the third STC, now we know it is written as 1x1 plus 2x2. We do not have s1 and s2 in the third STC, nor do we have the artificial variable 1 in the third STC. We have only a2, so therefore it will be given as 1 value in the third row. Now once this particular table is ready, we'll go for our computation work. The first computation row is Zj. Now Zj is being computed by using a standard formula, that is, we multiply the first column, the column that is given a heading as CB, coefficient of basic variable, with the values of the column for which we want the Zj value. That is, in the case of this particular column, we will get the value as 0 into 18, that is 0, plus minus m into 30, that makes it minus 30m, plus minus m into 26, that makes it minus 26m. So resulted would be 0, minus 30m, minus 26m. Sum it up, you will get minus 56m. Same thing would be repeated with the rest of the column, that is, over here it would be 2 into 0, minus 3m, minus m, which makes it minus 4m. The next column is also minus 4m. The next column is 0, m, minus m and minus m. Once you have got your Zj value, you will go to the last row, that is your Cj minus Zj row. Now Cj minus Zj row, as the term itself indicates, it is the first row which has been given a heading as Cj. From the values that have been given in the first row, you are going to subtract the values that you have computed under Zj. So the values would be 2 minus of minus 4m, which will give you 2 plus 4m. The next value is 4 minus of minus 4m, which will give you 4 plus 4m. The next term is 0 minus 0, therefore the solution is 0. 0 minus m will give you minus m. Minus m minus of minus m becomes plus m. So minus m plus m will give you the resultant 0. Similar case with the last column, minus m plus m will give you 0. Now once you have got all the values for Cj minus Zj row, we all know that when our problem is a maximization problem, a solution is said to be optimum when all the elements of Cj minus Zj row are either 0 or negative. So in this particular table, we see that there are two elements which are highly positive, that is 2 plus 4m and 4 plus 4m. Rest other elements are either 0 or negative. So we do not have issue with the remaining rows, but the problem exists with these particular two units. So any one amongst them would be our entering variable. Now which one would be the entering variable? Highest positive element would be the entering variable. So over here we are having 4m plus 2 and this term is 4m plus 4. This being the highest element, this variable, that is x2, becomes an entering variable. That means x2 is going to make an entry in the basic variable column. Now you have decided that x2 is going to make an entry in the basic variable column. Now the question is that x2 is going to enter in place of which variable? Because basic variable column is already being filled. That means one variable has to leave this particular column. The decision as to which variable would be leaving this particular column would be decided by our last column, which is called as minimum ratio. Minimum ratio is got by formula using solution value by key column element. Solution value column is known to you all. Key column element is the column which corresponds to the entry variable. That is, you have decided that this variable is an entry variable. So this column becomes a key column. So now when we proceed with it, if I use the formula, in case of first row, solution value divided by key column element makes it 18 divided by 1 makes it 18. 30 divided by 2 makes it 15. 26 divided by 2 makes it 13. So over here you see that